Right, type 3 graph analysis. I would assume due to the changes in the way that the 2020 AP exam is being created and administered, you can expect at least some portion of the AP exam, both AB and or BC, to have some sort of graph analysis type problem on the exam. All right, let's look at 2016 AB number 3. We're given the graph of F, and we're also given that our function g is defined as the area underneath the curve of f from 2 to x. And the first question asks whether or not g has a relative min, max, or neither at x equals 10. So understanding FTC number 2, when I take the derivative of an integral, I'm just going to get the function itself with that upper piece x in for t, and then it's really multiplied by the derivative of x, which in this case is 1. So g prime is equal to f, and g prime of 10 is equal to f of 10, which is 0. However, what is happening when x is equal to 10 on our graph? But f does not change sign, so we can say however, forgot that r, since g prime of x does not change sign when x equals 10, g of x has neither a relative max or min at x equals 10. All right, in part B, does the graph have a point of inflection at x equals 4? Well, we know since g prime equals f, then g double prime is going to equal f prime, which are the slopes of f. So we go up to our graph and we look at what's happening at 4. And at 4, the slopes are changing from positive on the left side of 4 and negative on the right side of 4. It does not matter that there's a sharp corner at 4. We're just looking at what the slopes are doing. So we can say since g double prime changes sign, doesn't matter what direction, positive, negative to positive, we know that g of x has a point of inflection at x equals 4. In part C, we're asked to find the absolute minimum and the absolute maximum value of g on this closed interval from -4 to 12. So we're going to use our candidates test. All of our critical numbers are -2, 2, 6, and 10. However, I'm going to eliminate 2 and 10 because there's no change in sign. And we're just going to look at -2 and 6. We also must look at the endpoints, because when we're looking for absolute extrema, we must include the endpoints. And so using the definition of g, which is the area underneath the curve from 2 to x, from when we're talking about -4, from 2 to -4 of f of x, we are going the opposite direction. So this is going to change the sign, and we are going to end up with the area above the x-axis will be negative, then the area below the x-axis becomes positive, and we get -8 plus 4 or -4. At -2, we're going from -2 to 2, and that area is -8 from up above, and we're trying to find when x is -4. At 6, we're going from from +2 to 6, and that area underneath the curve is that triangle, and we get 8. And then I'm going to check the endpoint 12. We go from 2 to 12. We're going to get 8 plus that 1/2 4 times -4, which gives me, and another 1/2 times 2 the base, and -4 there. And so we're going to get +8, the area above the curve from 2 to 6, -8, the area below the curve from 6 to 10, and -4, the area from 10 to 12, and we get -4. So when we're looking for an absolute value, an absolute max value, and absolute min value, we're going to give that as 8 for the absolute max and -8 for the absolute min. Part D, find the intervals on which g is less than or equal to 0. And remember, g of x is the area underneath the curve from 2 to 8. And so what we're looking for is we want it to be negative. So if we're going to start at 2, and then we go backwards, okay, this first area we got here was +8, but if we're going backwards, it becomes negative, and this part here would become +4, but we're still going to get negative values for g. So our first bit is from -4 to 2. Also, we know from 2 to 6, we're going to have positive area. From 6 to 10, this triangle and this triangle are similar, and therefore they cancel each other. So then anything here from 10 to 12 is going to also give us negative. So there we go. All right, BC 2014 number 3. However, AB students can do this as well. All right, so the first part is to find G of 3. G is defined as the area underneath the curve from -3 to x underneath f of t. And so I'm going to do that from -3 to 3. That happens to be a little triangle, and then plus a small piece that is underneath the x-axis. We get an answer of 9 there. In part B, we're asked on the open interval from -5 to 4, when is the graph of G both increasing and concave down? Increasing is the first derivative, so I want that to be greater than 0, and I want the second derivative to be less than 0. Remember, we know that G prime is equal to f, therefore G double prime is equal to f prime, which is our slopes of f. So from the graph, we want to know when f is greater than 0, but the slopes of f are less than 0. So we have two instances here from -5 to -3, where we have both positive above the x-axis but a negative slope, and also from 0 to 2. All right, part C, you're asked to evaluate or find h prime of 3. So we're going to find h prime, which is going to be the quotient rule, find the derivative there, and then I'm going to plug these values in. Now remember that G prime equals f of x. We know G of 3 from part A. We found an equation, or I found an equation of f of x, which is the equation of the line from 0, 4 to 4, -4. So that's that equation up here. That will allow me to find f of 3, which I got for b, -2. And so putting all those values in for h prime of 3, we get a final answer of -175 over 225. Now, you can leave it unsimplified. Part D, you have a composition P, which is equal to f of x squared minus x, and we're going to find p prime of -1. So the first thing we have to do is find the derivative of a composition. So I'm going to get the derivative of the outside piece, f prime of x squared minus x, and then times the derivative of the inside piece. Now, we also know that f prime of 2 is the slope of the line that we found in part C from 0, 4 to 4, -4. And so when I find f prime of 2, that's just the slope of the line that we found in part C, and then 2x minus 1 is -3, and so I get a +6. All right, 2016 AB with the table. We are asked to find k of x, where k is a composition, and we're asked to find the equation of the tangent line. So the first thing I've got to do is find the derivative of k, and then specifically k prime of 3, which I got a +10. Just go in from the table, I find all these values in the table. I also need to find k of 3, all right, and that's a composition, and again, these values come from the table, and I get 4. And so the equation of my tangent line is y minus 4 equals 10 times the quantity x minus 3. No need to simplify. In part B, we have a quotient. First thing I'm going to do is find the derivative using the quotient rule. I'm going to plug in 1 in all those places, simplify it and clean it up. Again, you can leave it unsimplified. My final answer, -54 over 36. All right, in part C, we're integrating from 1 to 3 f double prime of 2x dx. I'm going to use u substitution with that 2x, and I'm going to take the derivative of both sides. I have a constant of 1/2, which is going to have to go out in front. I'm also going to change the limits. So u of 1 equals 2, u of 3 is equal to 6. I'm just plugging those values 1 and 3 into 2x. So now I'm integrating f double prime, which is going to give us f prime, and using FTC number 1, that's f prime of 6 minus f prime of 2, and again, f prime of 6 and f prime of 2 comes from the tables. All right, AB 2017 number 3, we're given the graph of f prime, and we're also given that f of -2 is equal to 7. From FTC number 1, we know that the area underneath the derivative f prime from a to b is f of b minus f of a. You're going to use that quite a bit. So I'm going from -6 to -2 of f prime. That equals f of -2 minus f of -6. Rearranging things algebraically, we get f of -6 is f of -2 given in the stem of the problem, minus the area underneath the curve from -6 to -2 of f prime. That's going to give us an area of a triangle, and so that's 7 minus 4, or my answer is 3. So f of -6 is +3. We're also asked to find f of 5, so this time I'm going to go from -2 to 5, and again that's f of 5 minus f of -2 using FTC number 1. Again, rearranging algebraically, I find that f of -2 equal plus the area underneath the curve from -2 to 5 of f prime is going to give us f of 5. So I have f of -2, which is 7, given in the stem of the problem, and then plus we have a piece that's underneath the curve, which is half of a circle, and then we have a piece that's above the curve, which is our triangle, and that gives us 10 minus 2 pi. All right, in part B, it's asking you on what intervals is f increasing and to justify your answer. F is going to be increasing when our derivative is greater than 0, which means that we want to be above the x-axis. That's going to happen from -6 to 2 and 2 to 5. These are closed intervals on the endpoints because our function is differentiable on that closed interval. Part C is asking for the absolute minimum value on the closed interval from -6 to 5, and then to justify your answer. So again, whenever we're asked for absolute minimum, we're going to have to check our endpoints. So our critical values are at -2 and +2. However, -2 is a relative max since we're going from positive to negative in my first derivative, so I really don't need to consider that. We found f of -6 was 3. That happened in part A. We also found f of 5 in part A. So all we really need to do is look at what's happening at when x is equal to 2. And so that's going to equal f of -2 plus the area underneath the curve from -2 to 2 of f prime of x dx. All right, that gives us our 7, which is f of -2, and then that semicircle that's underneath the x-axis. So therefore, when x is equal to 2, f of x has a relative minimum since f prime changes sign from negative to positive. So we know that f of 2 is 7 minus 2 pi, which is also less than both f of -6 and f of 5, which are our endpoint values. Therefore, our absolute minimum value is 7 minus 2 pi. All right, and lastly, part D. You need to, for each f double prime of -5 and f double prime of 3, either find the value or explain why it does not exist. So f double prime of -5 is the slope of f prime at -5. And so I'm just going to use the 2 points, -6, 2 and -2, 0. Use the slope formula, change of y over change of x, and I get a -1/2. For f double prime of 3, that is the slope of f prime of 3, and we can see from the graph there's a sharp corner, and therefore that does not exist. Now formally, what you're going to use is you're going to say the limit of f double prime of x as we come from the left of 3, and the limit of f double prime of x as we come from the right of 3, those do not equal to each other, meaning the slopes coming from the left of f prime and the slopes coming from the right of f prime do not equal to each other.